Have you ever wondered how long it takes to boil water on the top of Mount Everest? A curious question, isn't it? It's one of those intriguing thoughts that take the mundane and toss it into the extraordinary. A simple, everyday task, boiling water, but we're not in our cozy kitchens, oh no. We're talking about doing it on the highest peak on Earth, where the air is thin, the wind is fierce, and the conditions are anything but ordinary. Well, you're about to find out. First, we need to grasp what altitude does to the boiling point of water. Now, anyone who enjoys a good cup of tea knows that water boils at 100 degrees Celsius, right? But here's the catch. That's only true at sea level. Let's dive a little deeper. What happens when you go higher? The air pressure decreases. Picture it like this. The air molecules at sea level are like a crowd of people in a concert. They're all packed together, creating high pressure. But as you climb up a mountain, those molecules start to spread out, like people leaving the concert. The higher you climb, the fewer air molecules there are above you, and the lower the pressure is. Now, you might be wondering, what does air pressure have to do with boiling water? Well, when you heat water, the molecules get excited and start to move faster. At a certain temperature, they have enough energy to break free from the liquid and become steam. This is what we call boiling. But if the air pressure is lower, like it is at high altitudes, the water molecules need less energy to break free and become steam. Therefore, water boils at a lower temperature as you go higher in altitude. So as we climb higher, the pressure drops and so does the boiling point of water. Now, let's dive into the science of boiling water. Firstly, what is boiling? Well, it's a phase transition from a liquid state to a gaseous state. This transition occurs when the vapor pressure of the liquid equals the atmospheric pressure surrounding the liquid, allowing bubbles of vapor to form within the liquid body. So, how does this happen? The process starts with heat. As we increase the temperature of water, its molecules gain more energy and start to move faster. When the water reaches a certain temperature, known as the boiling point, these energetic molecules have enough power to overcome the atmospheric pressure pressing down on the surface of the water. This is where bubbles come in. Bubbles in boiling water are pockets of water vapor. As the water continues to heat, more and more of these bubbles form and rise to the surface, releasing steam. This is boiling in action. But here's where it gets interesting. The boiling point of water isn't a fixed number. It changes with the pressure of the environment. The higher the pressure, the higher the boiling point. That's why water boils at 100 degrees Celsius or 212 degrees Fahrenheit at sea level, where atmospheric pressure is highest. As we go higher in altitude, the atmospheric pressure decreases. This lower pressure means the water molecules don't need as much energy to form vapor and escape as steam. Thus, the water will boil at a lower temperature. To illustrate this, consider a pressure cooker. When you seal the pot, you're increasing the pressure inside. As a result, the water needs to reach a higher temperature before it can boil, which cooks your food faster. On the flip side, in places with lower atmospheric pressure, like high up in the mountains, water will boil at a lower temperature. So, if you're making a cup of tea on a mountaintop, your water might boil before it reaches 100 degrees Celsius. So, the lower the pressure, the lower the temperature needed to boil water. Pretty cool, right? Now, imagine boiling water on Mount Everest, the highest peak in the world. Picture the piercing cold, the biting winds, and the thin air. At an astonishing height of nearly 8.5 kilometers, Mount Everest is unlike any place on Earth. The altitude alone sets Everest apart. The higher you climb, the thinner the air becomes. And this isn't just about needing extra oxygen to breathe. The thinness of the air, or rather the lower atmospheric pressure, has a direct impact on the boiling point of water. You see, ordinarily at sea level, water boils at 100 degrees Celsius, but every 1,000 meters you climb, the boiling point drops by about a degree. So at the top of Everest, we're looking at a boiling point of around 70 degrees Celsius. That's a drop of about 30 degrees just because of altitude. Then factor in the temperature. Everest is famously frigid. The average temperature at the summit is minus 19 degrees Celsius in summer and can plunge to a bone-chilling minus 36 in winter. These freezing temperatures mean that water will freeze almost as quickly as it boils, presenting yet another challenge to our boiling endeavor. So, with less atmospheric pressure and freezing temperatures, boiling water on Everest is a whole different ballgame. It's not just about turning up the heat and waiting for bubbles. It's a unique case of science and survival playing out on the roof of the world. So, how long does it take to boil water on Everest, you ask? Well, let's get right to it. Due to the decreased atmospheric pressure at such high altitudes, water boils at a lower temperature on Mount Everest. While at sea level, water boils at 100 degrees Celsius, or 212 degrees Fahrenheit, on Everest's summit. It boils at a mere 70 degrees Celsius, or 158 degrees Fahrenheit. Now you might be thinking, wow, I could make a cup of tea faster up there. But hold on to your teacups, because while the water may boil at a lower temperature, it doesn't necessarily mean it'll heat up faster. In fact, because of the extreme cold on Everest, it might actually take longer for your water to reach that lower boiling point. But let's say you're determined to have that cup of tea. What does this mean for you? Well, because the water boils at a lower temperature, the tea won't steep properly, leaving you with a rather disappointing brew. And don't even get us started on trying to cook. The lower boiling point of water also means that food takes longer to cook, since the heat isn't as intense. So, if you're thinking about whipping up a pot of pasta at the summit, you might want to reconsider. So, next time you're boiling water for your tea, just remember, it could be a lot quicker on top of Mount Everest.